Welcome everybody to Top Quadrant's first deep dive into TopBraid EVN. It'll be a multi-part series of short webinars where we take a close look at a particular aspect of TopBraid EVN. Today we're going to look at the new Autoclassifier, which we're very excited about. A few logistical items before we get started. Please feel free to ask questions as we go along by using the GoToWebinar controls. To post questions, please look on the right-hand side of the control panel. You should see a drop-down box for questions. If you click on the box, you should be able to post your question at any time during the presentation. We will address as many questions as we can at the end of the webinar. We will also be recording today's webinar, and we will send a link to the recorded version. Finally, in GoToWebinar, you should see a View menu at the top. If you click and select Full Screen View, you'll be able to see things in the best detail. So what we're going to look at today, first I'm going to give you an overview. I've been at this is Bob Ducharme, I'm sorry, didn't mention my name. I've been at Top Quadrant for about 6 years as a semantic solution architect, although I also help with other things ranging from sales to documentation. Richard Saganiak is a principal software engineer at Top Quadrant and the developer of TopBraid EVN Tagger's Autoclassifier. I've been involved in many semantic web related projects since about 2002, and I was aware of Richard's contributions to many important projects long before I joined Top Quadrant, so I was especially happy when he joined us. I'm going to talk at a fairly high level about what Autoclassifier can do for you and where it fits into the EVN family of products, and then Richard will show you Autoclassifier in action, and then time permitting we'll cover a couple of questions. So Top Quadrant as a company, our focus has always been on the practical application of semantic web technology to solve business problems. We offer a platform that lets customers quickly build agile, multi-user applications that take advantage of that technology, and we also use this platform ourselves to build applications that solve specific business needs. One of those applications is TopBraid Enterprise Vocabulary Net, or TopBraid EVN. EVN was designed to meet the kinds of needs of organizations that are doing more sophisticated vocabulary management to support the types of operations listed here on the left. EVN makes it easier for a multi-user team to manage a distributed network of vocabularies with different members of the team having potentially different levels of access for reading and writing vocabularies and deploying proposed changes. Now, people don't curate taxonomies and other vocabularies just for fun. They do it because the terms and metadata about the terms that EVN stores can be used to enhance the value of other applications and other information assets. We're going to see how Autoclassifier can play a big role in this enhancement. This shows some of EVN's key capabilities. I'm not going to read through the whole slide. You can find this information on our website. But I did want to highlight the last bullet because Autoclassifier also takes advantage of the workflow review infrastructure. In EVN, if I wanted to make 9 changes to a particular taxonomy, I could go in and edit the production taxonomy and everyone would see my changes right away. But what I'd be more likely to do is to create what we call a working copy. I could then edit that without affecting the production copy. I could grant coworkers like Richard the ability to work on these proposed changes with me, or maybe give them read-only privileges. We can manage this proposed set of changes, put it through a workflow, run reports on it before someone with the appropriate permissions actually puts these proposed changes into production. And we're going to see how Autoclassifier takes advantage of this working copy concept to make it easier to manage proposed changes. So this here we see a taxonomy published by the International Press Telecommunications Council and how it looks in EVN's web-based user interface when you're editing taxonomies. Or for something like this, a standard taxonomy, you might be creating your own custom version. The IPTC published this taxonomy using one of the open standards that we support, SCA, so we were able to just pull their taxonomy right up into EVN as shown. you can see that the term musical performance has been selected and it has a definition. And we could click the edit button and edit that definition or add more metadata, or we could add translations of the term musical performance in other languages to use in tagging other kinds of content or whatever we like. So that's EVN as an editing tool for editing taxonomies. Now this shows what we call Tagger for manually tagging concepts. In the upper right, you can see the same taxonomy that I was earlier showing in EVN itself, but with Tagger, it's being used to assign terms from this taxonomy to some content. In this case, several paintings. So we see that Diego Velázquez's Three Musicians is selected, and somebody has tagged it with the terms musical performance and food and drink. If this image was stored somewhere in a digital asset management system and I needed a good picture to go with an article in a travel magazine about restaurants with live music or something like that, the assignment of these tags to this image would help me find this picture and take advantage of this digital asset in my company's collection, and it would also enhance the article. So obviously, the more we can tag content such as images, or more typically articles, the more we can take advantage of that content and the greater we get out of it. If you have thousands and thousands of articles to tag, though, it can take a long time when done manually. So the Autoclassifier lets you automate this tagging process and then review the tags it assigned before putting them into production using the workflow feature. Instead of me showing you slides about that, I'm going to hand it off to Richard so that he can show you the real thing.
Perfect. Thank you, Bob. I would like to show a short demo of the Autoclassifier, and for this I'm going to use a scenario from the medical domain. We have a collection of medical content. It's abstracts for various kinds of medical documents, and we'd like to use the Autoclassifier to annotate these medical abstracts with terms from a medical thesaurus. And before I show these documents, I'd like to have a quick look at the thesaurus. It's the medical subject headings mesh, and so we have imported mesh into EVN, and so I'll just have a quick look at it here. This is the EVN main screen where you can see all the taxonomies that I have that I'm managing in this instance here. And so this is mesh here, and I'm just going to jump straight here into edit production copy. I'm not actually going to edit anything, but just show you what's going on here. So mesh is a thesaurus of medical terms, and so you can see it's a pretty large number of concepts. There's something like 26,000 concepts in here, and you can drill down and and then basically have a look at any particular concept. And this I just want to show really quick here in order to give you an idea of what mesh looks like. Going back to the main screen. So here on the top, there's these various tabs that allow us to look at the different kinds of things that are managed in EVN. So here are taxonomies. There's a couple of ontologies that we have as well, and then content tag sets. The content tag set is basically, so you can think of it as a container in which you can do tagging, so in which you can take content items and assign tags from taxonomies to them. And you've seen this tagged paintings content tag set there just a minute ago on Bob's slides. So I have this content tag set. I've created a content tag set here that's so it's called track, and this is, so you can see down here, it uses the concept vocabulary that we just looked at, the mesh taxonomy. So this is where the tags come from, and the content graph is, so this is basically the source of our documents. Now let's have a look at this. Again, gonna jump right in here. So in this collection of documents, we have, so the documents are organized by type here, so I can just sort of do a quick search for a particular type of document, for example, clinical trials, and then there's a list of results here, and now I could look at one of these. And what you see here is basically what a document looks like after it's imported into EVN Tagger. You can see, okay, we have a title, and then a number of properties here. So these are basically the various fields, metadata fields, and so on for this document. And so there's things like the creator, bibliographic citation, and most importantly, the text that you see here, this is the actual abstract. So this is the sort of a short description of this document. So this is the content that we want to work with in this case. And now here in the Tagger, so the other things that you can see here in this Tagger user interface over here is our taxonomy again. So this is mesh. And so, okay, and here I can look at the various, again, I can look at the various concepts. And down here, so yeah, and over here I can see that this particular document here has already been tagged with a number of concepts from the taxonomy. So this document here has been tagged with concepts like child, preschool child, clinical trials, and so on. And I could now, so if I wanted to, I could now just add the concept that I have selected over here. And you see that then the document actually appears here as one of the items that are tagged with this concept of bacteria. I'm going to remove that again because it's not actually accurate for this document. So this is the Tagger user interface, and this is basically where we can do manual tagging. Now the issue with manual tagging is that it can be very, very time consuming. To tag a document, what I would have to do is, yeah, probably, so I would select the document, I would read the title, sort of scan the content here, and then I need good knowledge of the concept hierarchy, of course, and so of the vocabulary, and I would then look for matching terms and make a subjective decision which ones are the best fit for this document here, and yeah, so which ones are basically the main topics as opposed to concepts that are sort of just mentioned in passing. And yeah, if I want to do that on a larger corpus of documents, then obviously this can be very time consuming. And that's the problem that the Autoclassifier addresses by automating this process as much as possible. So it's basically doing exactly the same thing. It looks at the text here and then finds matching concepts from the vocabulary and makes this subjective decision for us which ones are likely to be the best matches. And to do this subjective decision, it uses natural language processing techniques and machine learning techniques. The use of a machine learning algorithm means that it requires some training data to work with. What this means is, yeah, the algorithm wants to look at some example documents that we have already manually tagged, and the algorithm is then able to, so after we have automatically trained the algorithm with these manually produced example data, the algorithm is then able to recommend tags to us for any additional document that hasn't been tagged before. So let's have a look at that in action. So as I said, some of these documents are already tagged manually here, and others are not. So others don't have any tags yet. And now I'm going to go back here to the content tag set. And so there's various options here for the configuration of the content tag set, and one of them is the Autoclassifier configuration. And here there's a number of decisions that I need to make. For example, I have to say which of the fields of these documents I want to use in the auto-classification process. So the title and the abstract there, these are definitely useful. Others, like the identifier, they are not actually useful because they don't contain any text that that we could process. So I'm just not going to select them here. There's various knobs and switches I can turn. For example, here there's a threshold that I can increase if I get sort of too many low quality results, then I can apply a higher threshold here. This means that the algorithm will only show me results where it's more confident, or I can lower it to get more results of even where the algorithm isn't as confident. And yeah, we support these 4 languages in the current version: English, French, German, and Spanish. So now with these settings made, I can start the training. And as you can see here, so we have 1,000 documents in this document collection here, and 146 of these have already some tags assigned to them. So that's plenty of training data, and I'm just going to start the training. This will now run in the background. It'll take a little bit, but not very long. So in the meantime, I can just go over. Yeah, it's actually already finished. So over here on this Autoclassifier tab, we can now actually monitor, so run and monitor the Autoclassifier. So this button here will launch the Autoclassifier on the entire corpus of documents. So all these 1,000 documents. I'm just going to start this here, and we can see that now a job has been started over all the documents. And the time when it started, and okay, it's currently running. Again, this could take a little while, so in the meantime, I want to show another way how we can start the Autoclassifier. So here I'm back in the Tagger user interface. So again, I can do a search here for documents in my document collection by document type, and so I could also set up my content tag set to allow search by various other criteria. So here I can do a full text search, but I could also, if I had, for example, the creation date or the modification date in my as one of the fields here, and I don't have it in this data set, but if I have it, I could set this up to appear as a field here as well, and then I could, for example, search for only the documents that were modified this week or something like this. And then when I've done this search, then I can ask the Autoclassifier to only classify these matching instances. So with this click, for example, I've now started the Autoclassifier on just these 26 search results here. And so again, the job is going to run in the background. And now let's have a look here. So back on this monitoring tab, we can see now here's the job that I started first over the entire corpus that's completed, and then here's a second job over just these 26 documents, and that's is also completed. And yeah, now we can also look at the results, and here you will see, okay, these are our documents, and then I can see, okay, these are the results that have been picked here, and yeah, for example, so and these are basically the concepts that the Autoclassifier picked for these particular documents. Now, the next step would be, oh, I forgot to show one thing that I wanted to highlight as well. Whenever I start a job here, the results are, of course, not written straight to the production copy, because that wouldn't make any sense. So instead, we use this working copy mechanism that Bob talked about earlier. Basically, a new working copy is created, and the Autoclassifier will store its result in these working copies. So it's the same mechanism that we would use to do some changes in a staging area before committing them to the production copy. So here, for each of these 2 jobs that I ran, there's now a working copy here. And when I So and what I do here on this screen is basically review the results that have been stored in this particular working copy. And what I can do here now is I can decide, for example, I don't know what this is, so I'm going to reject it, and others said this looks okay to me, this looks okay to me, and then I could use these buttons here to bulk approve or bulk reject all the other changes that I haven't handled individually. And yeah, I'm going to actually now go to this result set here for the entire corpus, and just going to approve it all. And so this actually takes a minute, and while that is doing its thing, I'd like to address one question that I'm sure you're going to be interested in. So, how good are the results of this process? How good is this auto classification process? Is it sort of, how does it compare to what a human indexer would produce? And so the couple of slides that I'm going to show here are adapted from a presentation that the team that has developed this algorithm at the University of Waikato in New Zealand. So it's a presentation. It's based on a presentation that they have done. So the problem with talking about the quality of the auto classification results is that it's a subjective process. Because even if you have a number of human indexers that are experts in the domain, you will find that they asked to tag the same content, they would come up with potentially quite different answers. So, and this is quite well known in sort of a well-known phenomenon in the library world. And here's an example from a study that was done. This is about a document titled the Global Obesity Problem, and 6 professional indexers from the United Nations Food and Agricultural Organization were asked to assign tags from the Agravox thesaurus. And so what we find is these are a number of terms here that have been picked by most of these 6 indexers. Then here are many more terms that have been picked only by a few of the indexers, and then there's even more terms that just a single of the indexer picked. So there is actually not that much consistency between what the different expert indexers do when they're tagging. Now, oh yeah, and just to cherry pick 2 of these indexers, we see here. So the blue circles this is one of the indexers, the red is the other one. And on this particular document, they actually only agreed on the term overweight, and all the other concepts, if you look at them, they all seem to make sense. So there's nothing that you would call wrong in there, but it's just it just shows it's a highly subjective process. So how does the algorithm compare to this? The algorithm it's called the Maui algorithm, by the way. So we can throw it into the mix in a similar experiment. What you can see here is the results of a study that that the team did, where they asked computer science students to assign keywords to a number of documents, of computer science documents. Here you can see the different colored circles around some of these concepts are the different teams of students, and the green circle in the middle is the concepts that are picked by the algorithm. And so you can see there's only a few concepts that the students agreed on, and the algorithm picks most of them. And then there's a pretty large number of additional concepts that where there's not a lot of consistency between either the students or the algorithm. It would be good if we can quantify this a bit more. So the team came up with a measure of consistency for between these different collections of tags that the different teams and the algorithm produced. And so when they repeated this on 20 different documents, and they found so the measure of the consistency. So if you look at the numbers here, for most of the documents, so in the worst case, Maui did a little bit better than the students. In the best case, it did just a little bit worse. So on average, if you compare the consistency among the students, or then compare the consistency of the algorithm with the students, on average, you will get about the same result. And so we can say with some confidence here that the algorithm is competitive with the results that that human indexes produce. So that's a pretty encouraging result. In the meantime, so I just want to show one more thing here. Going back to my results. Going to edit production copy again, and now we can see here. If I drill down into the vocabulary, so here this concept, for example, there were no documents assigned to it, and now we can see there's actually quite a few documents that have appeared here now, and so now we can basically use this the taxonomy as a way of navigating this corpus of documents, and in a way that wasn't possible before. And this is because the autoclassifier has assigned all these terms to the documents. That's all I have, so I give back to Bob. Bob, if you're talking.
Thank you, Richard. I was just finding the right button to unmute myself, and then I'm going to take the screen back as well. Okay, so I was going to review some of the high-level benefits of Autoclassifier, and then we'll have time to we can stay a little past the half-hour mark to take some questions. So the key benefit of Autoclassifier is that you can add value to more content faster and at a larger scale. You can do this when you can add value to the content. This adds value to the applications that use the content, publishing applications, searching applications, things like that. It also makes it easier for your customers, your employees, your coworkers, depending on who's going to be using the content that you're tagging. It makes it easier for them to all find that content. Now, these two sub-bullets, adding value to the application, making it easier for people to find things, those actually apply to the manual tagger as well. But with the autoclassifier, you can scale way up because with manual tagging, if you want to double the amount you're doing per day, you need to double the amount of staff or double the amount of hours they're putting in, and that can get expensive as you scale up. Autoclassifier lets you scale much further up. Another nice feature, Richard showed how in addition to running as a batch, tag everything, which can take a couple minutes. It was easy to tag just a subset, to search for documents that meet a certain condition and then say just tag these. And we saw on this, when he went back to the status screen, I believe it took literally 1 second to tag that subset. Another nice thing is that there are various kinds of autoclassifiers out there, and this uses machine learning. I mean, you saw how Richard ran it with some training documents before he ran the test set, and there are ways to tweak. He filled out a form with various knobs and parameters to tweak to sort of fine-tune how it does its tagging. By using machine learning as opposed to rule-based system, there are auto-tagging systems, autoclassifiers that use rules that you have to write yourself. And if the tagging doesn't go the way you want, you have to create more rules or maybe debug existing ones or the relationships between them. You don't have to do that. Here, the system takes care of all that for you. The review process lets humans have the last word, so you get the best of both worlds of the algorithmic tagging and human subject matter experts who, instead of reading through these documents and tagging them, can just sort of approve whether they made sense at a granular level or at a higher level. And we didn't talk too much about how well this, like anything running on the TopBraid platform, integrates with other systems using APIs. Other systems can call it using RESTful web services. There are ways to have it call other systems so they can communicate back and forth. So we have, I'll come back to that. We have some time for a few questions, and I see there are two sort of complementary questions I wanted to address together. Somebody asked, are SCOS collections supported? And somebody else asked, do the terms that you tag with have to come from a SCOS taxonomy, or can you use an ontology? Earlier, when I showed the IPTC taxonomy, I mentioned how when this group published the taxonomy, they published it using this standard SCOS that our tools support. So that's why I was able to just read their taxonomy right in, and we could see it in EVN with no scripts to prepare it or rearrange it or anything. It worked out of the box. SCOS is the W3C standard model for taxonomies, and one great advantage of SCOS is that along with the other kinds of metadata that you store with vocabulary terms, you can store synonyms. So, for example, if a vocabulary stored Motrin as a synonym of the term ibuprofen, and the autoclassifier found Motrin being mentioned in a document, it could tag the document with the term ibuprofen if that was identified as the preferred term in the taxonomy. So when you use Autoclassifier with SCOS taxonomies, it can really take advantage of a lot of that. So that's like what Richard was doing there. He was using a SCOS-based taxonomy. A lot of standard vocabularies out there, especially in life sciences, are actually stored as ontologies, which typically serve more of a data model role than taxonomies do. But they can still be used as controlled vocabularies. The current release of Autoclassifier can use ontologies for tagging after a few tweaks to them, tweaks that can be automated, and the next release will make it even easier. Let me take a look. Other questions we have. We have a question here, how does Tagger find the content to tag? We have ours in a CMS. When Richard showed the manual Tagger, we saw how each document had several paragraphs making up its content, and that's what the Autoclassifier was analyzing to decide which terms to assign. So I guess the question is, how does your content get to where Tagger and the Autoclassifier can work with it? There are two options. One, if you can do a batch export of content from your CMS, there are ways to get it into the standards-based format that the Autoclassifier can read and analyze. If it can't be read in directly, sometimes it just takes a little scripting to prepare that content. Also, if your CMS or other tool has a documented API, content can be handed off to the Autoclassifier dynamically, which is especially useful when new documents are added to the CMS. Okay, here someone has asked a performance question. How long would it take to tag 20 million documents against a taxonomy of 1,200 terms? Richard, you've got more experience with the sort of technical tuning and also, how would you address something of that scale?
Yeah, so 20 million documents and a taxonomy of 1,200 terms. So the size of the taxonomy isn't much of an issue here. It doesn't really affect the performance of the tagging process or the speed of the tagging process. It only would affect the learning, how long basically the training process takes. And 20 million documents, well, so the good news is that the auto tagging of documents is so it's a simple process where each document is taken individually and is processed individually, which means if you have 10 times more documents, then it just takes 10 times as much time. So it scales linearly with the number of documents and also with the size of the content in the documents, in case your documents are large. And yeah, of course, this will depend a lot on the hardware, but just to give you the example, so the example that I ran here, there was 1,000 documents, and that takes about 30 seconds on a run-of-the-mill laptop. So you can sort of extrapolate from that. I'm not going to break out my calculator now to work out what it would be for 20 millions, but it scales linearly. Yeah, it's a batch job that runs in the background. And yeah, we're basically prepared the system is prepared to deal with large numbers of documents.
Okay, so the important thing is that it scales linearly. when you're putting training sets in, how large of a training set would you, like how many documents do you think is appropriate to prepare the autoclassifier to then handle the untagged documents? Like how large of a training set would be good?
You want me to take the question?
Oh, yes. Oh, I'm sorry. Yes, I'm asking you. Well, you know better than I do.
Yeah. Well, yeah.
There's numbers involved.
Well, it's so this is again a subjective question. It depends a lot on the particular corpus that you have and the taxonomy that you have. But I can certainly mention some rules of thumb. So if you have, if you have very few training documents, I should maybe mention first so the problem that we're dealing with here is, of course, a well-established problem in computer science: the assignment of subjects to content. So it's automatic subject indexing. It's well studied. There's different algorithms that have been proposed over time, and the issue with many of the algorithms is that they require a lot of training data. In particular, most algorithms require examples for every concept that you have in your taxonomy. And in the case of something like mesh that has 26,000 concepts, of course, it's not practical to, in many cases, it will not be practical to produce that much training data. So that's why we chose this particular MAUI algorithm, because it performs well even on very realistic amounts of training data. So let's say if I had just 20, 30 documents manually annotated, it would produce results. The quality of the results would probably not be quite what I would want. But for serious users, I would say you'd want to have at least sort of 100 training documents. And at the point when you have about 1,000, then adding more actually doesn't change the results anymore. So there's diminishing returns to adding more training data. And there's also such a thing as too much training data, actually, because let's say if you had 10,000 documents, you're going to get, so if you had 10,000 training documents, you would get pretty much the same results, and the training would just take longer and take more memory. So in that case, we would actually recommend that you just pick 1,000 from these 10,000, and that would get the job done perfectly.
Okay, that just about covers the time that we have. I know there are a couple more questions, but we will be in touch with the people who asked them to address those questions. And also, if you think of more questions later, you can email us at the address shown here. You can find out more about TopBraid EVN, the manual tagger, and the Taxonomy and Ontology Manager. You can actually request your own, we can set up your own remote server for you to try it out if you like, so we'd love to tell you more. Thank you very much, Richard, and thank you all very much for joining. We're going to make a recording of this available soon, and watch for the part 2 of our deep dives into TopBraid EVN.